Hello fellow stargazers, I hope mko best. Welcome to another show. My name is Professor Joe and this is Kenya Space Talk. Now today I want us to talk about black holes. In our last episode we talked about the birth, life and death of a star, and tulisema massive stars it goes out with drama, so inalipuka, inaweza kuwa a neutron star ama inakuwa a black hole. Now this black hole ndo nataka we look at it today. After the star ina undergo supernova, what happens is that the core is shrinked or is rather compressed into a very small infinitely dense point known as point of singularity. The space around the point of singularity now is known as event horizon. It is an imaginary boundary, but how we know this is where the event horizon starts? It's because that's where the darkness starts in. Kwa sababu what happens is that si ati hakuna light. Now remember, black hole has a very massive gravity. Even light itself cannot escape. So when you look at it, there is no light that was reflected from that point of view ikaletwa kwa your eye to observe. So what happens, utaona pakiwa dark, and that's why we see the black holes zikiwa black. Actually that's where the name came from, black hole, because no light can escape. But it's not that there is no light, there is light there, but it's been sucked inside the black hole towards the point of singularity. So I know most of you mnadhani these stories are black hole ni jaba. Have you ever watched that movie? It's called Interstellar. It's a movie that talk about black hole gigantua. Is it called gigantua or something? Anyway, black holes are real. We actually spotted one in 2019 and it was photographed. It is at the center of the galaxy M87. Now ukiingia sasa ndani past that event horizon, what do you expect to see? Black holes gonna gravity kubwa sana to an extent it sucks everything, all stars, all planets, anything that it comes across, or anything that its gravity influences enough to pull it inside, inaanza kuivuruta. Now once imefika at event horizon, inaanzanga kustretch in a process we call spaghettification. Now ukishavuta huko ndani, you are pulled towards the center of the black hole. Remember to tuliita aje? Point of singularity. This is where the laws of physics don't occur. Nobody knows what happens there. Scientists have tried explaining with calculus, but at the end of the day, physics does not conquer there. It's an area of mysteries. Black hole stays in space, affecting gravitational-wise other matter such as planets and stars, the formation, e.g. At the center of every galaxy we have a black hole, including our own Milky Way galaxy iko na black hole katikati inaitwa Sagittarius A star, and the gravity of those black holes help a lot in shaping the galaxy. You can say it's as if they control what is happening in the galaxy. So as they say, everything that is born dies eventually. So pia black holes was nakufa. And how do they die? So remember, we had a scientist called Stephen Hawking. I think he died recently in 2018. Stephen Hawking discovered how the black holes die. Remember, at the event horizon, everything is sucked inside the black hole. Now, at that surface, we also have matter, or let's say particles and antiparticles. So what happens is that unapata at the surface, those two particles and antiparticle, one goes inside and the other one comes outside. Now, as a result of that process, we call it Hawking's radiation. You find that the black hole will start losing mass as every time one particle escapes and the other one disappears. Remember, for every particle, there have to be an antiparticle. Eventually, everything will end up inside the black hole. So, black holes ndo zitabaki roaming the universe alone zikiwa peke yake, and then eventually through Hawking's radiation, after billions and billions of years, zitapungua pizo in size, in mass, ziishe, and the universe will be left empty. So, before signing off, I like to tackle one question from a comment, and it says, why do time slows down near a black hole? Interesting question. Remember, a black hole has gravitational pull. And in Albert Einstein's general theory of relativity, we expect a black hole juu iko na gravity mingi bend space around it. Remember, light travels in the straight line. So let's say an empty space, light ikipita hapo itapita too straight. But tukishaeka maybe the sun, we place the sun in that empty space void, the sun is going to bend the fabric of space-time around it. So what happens is that when light passes, it's going to seem like it's bending. It's following what we call a geodesic path. But it's not that the light is bending, but the space around the star or the black hole or the massive object in space is being bent by the gravity of the objects. Now, I wrote a paper about time is an optical illusion. I'm going to link it in the description below. Where in my paper, I tried to show that without light, you cannot tell time is moving. And that's why ukiwa umefungiwa kwa in a very dark room, ujuangi siku zikienda, uwezi jua ni usiku, uwezi jua ni mchana. That's because you cannot perceive the passing of time. That's why I normally say light gives us the illusion of time. So we find that if light is being bent, and this light is supposed to give us the illusion of time passing through the circadian rhythm. It's called a circadian rhythm. It's our internal brain clock controlled by light. Asubuhi inafika, unajua ni asubuhi. Jioni unajua ni jioni. Jioni the body hormones and nerves zina relax because of the circadian rhythm, because it detects the passage of time. So that still circadian rhythm is still the one which gives you the illusion of time is passing. Just as the light is being bent near the black hole, that's the same light that gives us the illusion of time is being slowed. Now, according to that question, I would like to leave you with just a question. Is light and time related? Leave your answer in the comments below. See you next time.